Hi everyone, welcome to this video on XML structured prompting. Today we are going to talk about something that is very practical and very useful for all of us who work with AI models like Claude, GPT, and others on a daily basis. The idea is simple. Instead of writing your prompts as one big paragraph of text, you structure them using XML tags. This gives you much better control over what the AI does. This presentation is based on a recent research paper by Alpe and Alpe from 2025 and also the official Anthropic documentation for Claude. So let us get started. So first question, why should we even bother structuring our prompts? See, when you write a normal free-form prompt, there is a lot of ambiguity. The AI has to guess which part is the instruction, which part is the data, which part is the constraint, and many times it guesses wrong. The research paper says it very clearly. Structured prompting with XML tags has emerged as an effective way to steer LLMs toward parsable, schema-adherent outputs. Think about it from a developer perspective. If your output is not structured, how will you parse it in your code? How will your pipeline handle it? That is where XML prompting comes in. Three main problems with unstructured prompts: ambiguity, inconsistency across runs, and outputs that are impossible to parse reliably in production. Now, what exactly is XML prompting? It is basically using XML style tags, like opening and closing tags, to clearly separate different sections of your prompt. You wrap your instructions in instruction tags, your data in document tags, your desired output format in output underscore format tags. Simple as that. Look at this example on the right side. See how clean it is? The AI knows exactly what to do, what data to look at, and how to format the response. The Anthropic documentation says that XML tags help Claude parse prompts more accurately, leading to higher quality outputs. And this is not just for Claude, this works well with most modern LLMs. The key benefits are tags act as boundary markers, each section gets its own purpose, there is no mixing of instructions with data, and the output becomes easy to parse programmatically. Now let us look at the main tags that you will use most often. First is the instructions tag. This is where you tell the AI what to do. Keep it crisp and clear. Context tag for background information. Maybe you are giving domain knowledge or company specific information. Examples tag for few short prompting. You give one or two examples so the AI understands the pattern. Document tag for the actual data or text that needs to be processed. Output underscore format tag, very important. This tells the AI exactly how you want the response structured. Constraints tag for rules like maximum length, tone, audience, etc. And thinking tag, this is for chain of thought reasoning. You ask the AI to think step by step before giving the final answer. One important thing, Anthropic says there are no canonical best tags. Use whatever tag names make sense for your content. Just be consistent across your prompts. So you might ask, why XML specifically? Why not JSON or Markdown or YAML? Good question. Let me explain. XML supports deep hierarchical nesting. You can have tags inside tags inside tags. This maps perfectly to complex multi-step tasks. XML provides clear context separation. The opening and closing tags make it absolutely clear where one section ends and another begins. No confusion. XML is self-documenting. When you write a tag called review underscore criteria, everyone knows what it means. Both the developer and the AI understand it. XML outputs are very easy to parse. You can use any XML parser in any language to extract the specific sections you need. Models like Claude are specifically trained on XML structured prompts, so they respond better to this format. And finally, composability. You can treat your prompt sections like code components. Reuse them, version them, share them across your team. The research paper also mentions that XML remains attractive where schemas and mixed content matter. Let us now see a real practical example. Imagine you are building an AI-powered code review tool, maybe integrated with GitHub Actions. Look at this prompt on the left. See how cleanly it is structured. The task tag clearly says, review this code and provide detailed feedback. The code tag contains the actual code to be reviewed. You can swap this out for any PR diff. The review underscore criteria tag has nested tags for each dimension: security, performance, maintainability. This is very powerful because now the AI will check each of these separately. And the output underscore format tag tells the AI exactly how to structure each issue: location, severity, description, and fix. Why does this work so well? Because the task is isolated from the data. You can change the code without touching the prompt. The nested criteria give granular control, and the output is parsable. You can feed it directly into your CI/CD pipeline. This is production ready prompting, not just playground experiments. If you are building any kind of document question answering system, this pattern is gold. See how the documents are indexed: document index 1, document index 2. This allows the AI to cite its sources properly. The instructions tell the AI to first extract relevant quotes from the documents, put them in quotes tags with the document index, and then answer in answer tags. Why is this pattern so powerful? Four reasons. First, documents are indexed with explicit references for citation tracking. Second, the AI extracts quotes before answering. This is very important. It reduces hallucinations because the AI grounds its answer in actual evidence from the documents. Third, the XML output tags make the response trivially parsable. You can extract the answer section separately from the quotes section. And fourth, this exact pattern is actually used in production RAG systems with Anthropic Claude. This is not theory, this is real world architecture. Now let us look at some advanced techniques where you combine XML with other prompting methods. First, chain of thought plus XML. You use a thinking tag where the AI reasons step by step, and then an answer tag for the final response. This forces the AI to actually think before answering, rather than jumping to conclusions. Second, few-shot plus XML. You put your examples inside examples tags, with each example having its own input and output tags. The AI learns the pattern from these examples and applies it to your actual task. Zero ambiguity about what is an example and what is the real task. Third, agentic tool calls. This is for more complex AI agent workflows. The AI creates a plan, gathers evidence from tools, and produces an answer, all structured as XML subtrees. The research paper actually proves that these kinds of protocols converge to well-formed outputs when you use XML structure. This is where XML prompting really shines, when things get complex and you need reliable structured behavior from the AI. Let us do a quick comparison of XML with JSON and Markdown. For nesting depth, XML is excellent for deep hierarchical structures. JSON is also good with nested objects. Markdown is limited. You only have headers and lists. For human readability, XML is quite readable because the tag names themselves explain the content. JSON is moderate. All those curly braces and quotes can get messy. Markdown is the easiest to read. For LLM compatibility, XML is excellent, especially with Claude and newer models. JSON is good, particularly with OpenAI function calling. Markdown works generally well. For output parsing, both XML and JSON are trivially parsable with standard libraries. Markdown is very difficult to parse reliably. For mixed content, XML is excellent because you can have text, attributes, and nested elements all together. JSON is poor at this. Markdown is okay. So the bottom line: use XML for complex multi-part prompts. Use JSON for API and function calling. Use Markdown for simple documentation style instructions. The research paper actually notes that JSON typically yields higher parsability in some clinical extraction tasks, but targeted XML prompting narrows the gap, and XML remains the better choice where schemas and mixed content matter.